Hello and welcome to this AQA Further Math Statistics video, Discrete Random Variables 4, and we're going to be looking at the expectation and variance of different functions of a random variable. So this is just a bit of a reminder about what you should know from the earlier series of videos on expectation and variance. You should be familiar with the formula for expectation, sigma xi pi, and also the formula for variance, ex squared minus e of x, the mean, squared. And remember that this is something that's very easy to forget to do. And we'd also previously looked at the expectation of a linear transformation of a random variable. So e of ax plus b, where a and b are constants, is a multiplied by the expected value of x plus b, and the variance of ax plus b is just a squared multiplied by the variance of x. So in this video we're going to be looking at extending those ideas to include different types of functions of our random variable. So going from our original definition, we're going to be looking at the fact that the expectation of a function of x is the sum of that function of x multiplied by the probability. So you'll probably recall that you've actually used this already, because when we worked out ex squared for the variance, you were used to using this formula here, sigma xi squared pi. So this example is looking at a random variable x with outcomes 1, 2, 3 and 4, and those are given across this top row in the probability table here, and we're asked to find the expectation of x cubed and 2 over x. So just take a moment and check that you are familiar with how this probability table works, that each probability here links to the probability of their getting that particular outcome. So we've been asked to find the expected value of x cubed. So if you think about g of x being x cubed, we are going to have to find here sigma xi cubed pi, and we can fill that in on a separate row here, a new row in our probability table. So 1 cubed, which is just 1, multiplied by the probability x takes the value 1, 2 cubed, multiplied by the probability x takes the value 2, 3 cubed, and so on. And here you can see all of those values filled in for you, and the outcomes are given here at the bottom. And obviously our e of x cubed is the sum of these, so these are all being summed at the bottom here, and we get 1274 over 30, or 42.5, correct to 3 significant figures. So ex cubed is 42.5 to 3SF. If we now followed the same theory with our function 2 over x, so this is something quite different. We want 2 over x, then just following this rule, our g of x is 2 over x, so it would be 2 over xi multiplied by the probability of getting that outcome. So we would have 2 over 1 multiplied by the probability of getting 1, 2 over 2 multiplied by the probability of getting 2, etc. And that's all nicely written out for you. And again, our expected value of 2 over x is the sum of all these individual items, and that gives us 32 over 45, or 0.711 to 3 significant figures for the expected value of 2 divided by x. So if we now look at the variance of a function of x, this is our initial general definition. If we put in a bit more detail, then ex squared from what we did before would be sigma xi squared pi, so each value of x that's possible squared multiplied by the probability of getting it, minus the mean, which is sigma xi pi, all squared. and we're going to extend that to the variance of any function of x, and again it's going to be sigma whatever that function is all squared multiplied by the relevant probability minus sigma that function multiplied by the relevant probability all squared. And again, you know, this part is the part that's very easy to forget to do. So if we go back to our example and now look at finding the variance for x cubed and 2 over x, you might like to just pause and have a think for a moment about how you think you're going to do this. So we want to find the variance of x cubed. So that's actually going to give us sigma xi cubed, that's our function, squared multiplied by pi minus the expected value of x cubed, and that is all squared. And of course the expected value of x cubed we've already just found out, so this is the thing we're going to focus on finding, sigma xi cubed squared multiplied by pi, and hopefully you can see that x cubed squared will give us x to the power 6. So what we need to work out is x to the power 6 multiplied by the relevant probability in order to get what's equivalent to our ex squared, but e of gx squared this time. So we'd have 2 to the power 6 multiplied by 4 over 30, 3 to the power 6 multiplied by 8 over 30, etc. And this is all written out for you here. And we have the final answers at the bottom here. Quite nasty fractions, but it's worthwhile keeping them exact and using the calculator in fraction mode. And to find our variance of x cubed, we need our ex cubed squared, and that's this first bracket here, minus our mean ex cubed, which is what we worked out in the first part of this video, squared. So don't forget this minus the mean squared. And so you can check that that gives you 584, not exactly, but correct to 3 significant figures. So we have our ex squared equivalent, so our ex cubed squared in this first bracket, and then we are subtracting our mean squared. And finally the variance of 2 over x, so again our g of x is a different function again this time, and that would be sigma 2 over x squared multiplied by the relevant probability minus the mean of 2 over x, which again is what we worked out in the first part of this video, squared. So if we focus on our ex squared, or our e of 2 over x all squared this time, we're going to need 2 over x squared multiplied by the relevant probability, 2 over x squared multiplied by the relevant probability, 2 over x squared, and 2 over x squared. So just stick with the basics, you know, don't try and do anything clever here. This is the way you need to approach these sorts of problems. And there you have all the workings done for you. So our variance of 2 over x is this first bracket here, which is our e of 2 over x squared minus our mean squared. So again, you know, try not to forget that, and that's what we worked out earlier, and that will give us 0.146 to 3 significant figures. And that concludes this video.